Sir Isaac Newton, an English physicist and mathematician, formulated three fundamental laws of motion that are collectively known as Newton's laws of motion. These laws laid the groundwork for classical mechanics and have been crucial in understanding the behavior of objects and the motion of celestial bodies. Let's explore each of Newton's three laws. 1. Newton's first law of motion, law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity unless acted upon by an external force. This law is often summarized as objects tend to stay in their current state of motion, or rest, unless a force is applied to change that state. In simpler terms, if an object is stationary, it will remain stationary unless something pushes or pulls it. Similarly, if an object is moving, it will continue moving in a straight line at a constant speed unless a force alters its motion. 2. Newton's second law of motion, law of acceleration. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, this law is expressed as F equals ma, where F is the net force applied to an object, m is its mass, and is the resulting acceleration. This law states that the greater the force applied to an object, the greater its acceleration will be. Additionally, the more massive an object is, the harder it is to accelerate it with the same force. 3. Newton's third law of motion, action-reaction law. For every action, there is an equal and opposite reaction. This law states that when one object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. In other words, if object A pushes object B with a certain force, object B will push back on object A with the same force, but in the opposite direction. Newton's laws of motion have become fundamental principles in classical mechanics and have played a crucial role in shaping our understanding of the physical world. These laws are applicable to objects of various sizes, from everyday objects on Earth to the motions of planets and celestial bodies in the universe. They are a cornerstone of modern physics and have laid the groundwork for further scientific exploration and discoveries.